Hello and welcome back to our this is already the third take. This is the flip book that says polynomial on the front. I did it. Polynomial. Yes, that's what it says on the front of this flip book. This is already my third take because I can't say that word for some reason. So we're just gonna move on, and I'm just gonna leave that in there, and whatever. We are on page 13, and we are going to factor using the distributive property. Now, I'm going to say that this I'm about to change your life, I think, because I'm about to teach you factoring using distributive property. That's whatever. That's just one of the tools we're going to put into our toolbox. We've been putting a bunch of tools into our toolbox, but this right here, this is gold. Gold, I tell you, gold. Okay, so let's talk about factoring using the distributive property. Basically, I want to be able to take this thing right here and simplify it in a different way this time. And it's going to make sense why we're simplifying it in this way as soon as we get down here. But we want to take this and we want to be able to write it in a different way. And we're going to do that by using the distributive property. Now, you know the distributive property. That is A times the quantity of B plus C. Write that down. Equals, well, that's A times B and A times C. Okay, so A times B plus A times C. Okay, so you learned this in 6th grade. You've been using this for a very long time. We've done this a lot. We use this a lot in solving equations, blah, 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 blah. We've already done it in this flip book. But now we're here. Okay? This is this right here. And I want you to be able to now go from here to here. Okay? I want to be able to pull out some common factor and write it like this with parentheses in it. Because if I do that, I will get rid of this squared nature of this thing, and it'll unlock a lot of options for me, and you'll see what I mean in a second. But let's talk about what it looks like to factor using the distributive property. Okay, so first step, we are going to find the GCF of the coefficients. For those of you that do not remember what a GCF is, that stands for greatest common factor. And your 6th and 7th grade math teacher spent a lot of time teaching you about a GCF, and you're probably like, well, why do I need that? Well, here it is. Like, isn't that a lot of math skills we learn, right? We learn it at one time. We're like, why do I ever need this? And all of a sudden you're like, ooh, I wish I would have learned this better. So hopefully we're pretty good at greatest common factor, and we can use that in this lesson. Once you've found the greatest common factor of the coefficients, I want you to find the greatest common factor of the variables. Finally, we are going to factor by dividing. Said differently, we are going to take whatever GCF I can find in each of these terms, we'll call that our A, and I'm going to pull it out front of our parentheses. And whatever's left over after I've divided by whatever A is will be our B and our C inside these parentheses. So let's look at what this means. Let's find the GCF of the coefficients. So basically, what are these two numbers both divisible by? What is the biggest number I can come up with they're both divisible by? I think you can all hopefully see that the GCF right here is 4. Now we're going to look at the variables. GCF of the variables. What can I divide both of these by? Well, I could divide this by x squared, but I can't over here. There's not x squared here. There's just an x. So this has just an x. This, of course, has two x's. So I can at least take out one of them. So that is going to be my GCF of the variables. Finally, we're going to be factoring by dividing. Basically, I'm going to take this GCF. It is 4 and x. I'm going to divide both terms by it. Well, the first thing I'm going to do is I'm going to write that out front. That is what I found in both terms. I know that there is a 4x in both of these things. So now that I know that, I can pull that out or divide both of these terms by 4x. If I divide this by 4x, this 4 goes away, and one of the x's goes away, and I'm just left with an x inside. If I divide this by 4x, well, 24 divided by 4 is 6, and x divided by x is 1, or it goes away, right? And that's what I'm left with. We can check real quick if we want to. We can do 4x times x, and I get 4x squared. And I can do 4x times 6, and I get 24x's. So we see this pattern. We started here, we went here, and then I just showed you, well, to check to make sure you did it right, you can do the distributive property as you know it again, and you should be right back here. Okay? So if I can move from here to here, I should be able to also move from here to here and get something that is completely equivalent to what we have. So let's try it a couple more times before you get a try on the next page. Feel free to pause and try on your own. I am looking for the GCF of the coefficients. Well, divisible by 3, still divisible by 3, still divisible by 3. So it must be 3. And I could just look over here at the smallest variable right here is x. These all have an x. This, of course, doesn't have more than 1, though. So I'm going to be pulling out an x as well. That's the GCF of my variables. Well, if I divide this by 3x, I just end up with x squareds. If I divide this by 3x, I end up with a negative 4x. And if I divide this by 3x, I end up with a 5, and x, those go away, and yada, yada, yada. If I pull out an x, look, each one of these should be one smaller, right? And you can check 3x times x squared, well, that is 3x cubed. 3x times negative 4x is negative 12x squared. 3x times 5, well, that's 15x, so we did that right. Ooh, this is a little bit more challenging, but if we move from left to right, if we do our coefficients and then our variables, it should be doable. So 16, 12, 8. I think those all have 4 in common, so I'm going to pull out a 4, a squared, a, and a to the third. Well, the lowest term here is a, so that's all I'm going to be able to pull out for the a's. And I've got b, b cubed, b squared. So b is also the smallest I have. So that is all I can pull out. And now we're going to go through each term and make sure we get the right thing. So 16 divided by 4 is 4. A squared divided by a, well, that just gives me 1a. B divided by b, well, that's 1, or those go away. So I'm on to the next one. 12 divided by 4 is 3. A divided by a, well, those go away. Those cancel out. B to the third divided by b, well, that gives me b squared. 8 divided by 4, that gives me 2. a to the third divided by a, that gives me a squared. And b squared divided by b, well, that gives me b. And I'm done. If you want to do the distributive property on that, you're going to see that we did it perfectly because I'm the math teacher. No, because we thought through it really carefully. Okay, so here it is. Mind-blowing moment. You are about to learn the zero product property. You did not know until now that you are missing something in your life. That thing is the zero product property. It is so important. You are going to use it again and again and again and again and again and again and again. Basically, all the rest of this semester, we're going to be using the zero product property, especially for chapters 8 and 9. And then guess what? You are going to move on to Algebra 2 next year, and you're going to use it all year long. Like, if you don't understand the zero product property, well, it's going to be a sad year for you next year. But we're going to understand it. We're going to get there. Even if you don't understand it today, that's okay, but we'll get there. Okay? So the zero product property, I hope you've already been writing it down while I've been rambling on. It says if the product of two factors is zero. So if I'm multiplying two things together, here's an example, a times b. If it equals zero, okay? If the product of two factors is zero, then at least one of the two factors, so either a or b, at least one of the two factors must equal zero. So here it is algebraically. If a times b equals zero, then we know, because it has to be, we've proved it mathematically, it only makes sense that if a times b equals zero, then either a has to be zero, because 0 times b, or 0 times anything is 0, or b has to equal 0 because a times 0, or anything times 0, does equal 0. Or, of course, they both could be 0 because 0 times 0 does equal 0, okay? So we're going to use this idea, and we're going to come back to this thinking, but this is a complicated way of saying something kind of simple, right? Okay, so we are saying that 4x times the quantity of x plus 3 equals 0. Now, what I'm telling you is I have a multiplication sign right here, right? The product of two factors. Oh, here's a factor and here's a factor. So what we're really saying is we're not saying 4x times the quantity of x plus 3 equals 0. We could really say we're saying a times b equals 0. So if I could figure out a number that makes a 0 or a number that makes b 0, I will have figured out a way of solving this equation. Now, the cool thing is we're going to have two solutions almost always. And I will tell you at a later date when you won't have two solutions. But right now we're thinking two solutions, okay? So if I can make this 0 or I can make this 0, then this is going to be a true statement. I will have solved for x. Okay, so let's solve for x. So either a can be 0. So what would make a 0? Well, if I just set this equal to 0, I can solve it. Oh, x equals 0. Oh, that makes sense. 4 times 0 is 0. And anything, 0 times anything is going to still equal 0. Okay, so I also could make this thing inside here 0. Well, just subtract 3 from both sides, and I get that x equals -3. Okay, so here's my two solutions. Oops. Okay, so, and that makes sense, right? -3 plus 3 is 0, and anything times 0 equals 0. Okay, so my two solutions then, x equals 0 or x equals -3. Let's try it again. Okay, so we've got this thing, and they set it up for us. We've got a times b equals 0. Okay, so if I've got a times b equals 0, you'll know if there's no exponent here that it's ready to go. It's ready for you to figure out what makes it 0. Well, we already know that this is going to be 0, right? if I set this equal to 0, divide by 5, m equals 0. For some reason, this gives some students fits, though. When I've got something out here, they forget to do this thing, because we're going to practice doing something that looks like this so much. But don't forget, when I just have a variable times something in parentheses, well, 0 is going to be one of my solutions. The other solution is hidden in here. So I can subtract 8 from both sides, and I get negative 8 equals 4m. I'm going to divide by 4, and m equals negative 2. And there is my second solution. So we've just solved for m. We found that m has 2 solutions, and we are ready to move on to D. Okay, you notice D, you notice this square right here, okay? That means I'm not ready for you to apply the zero product property yet, because there is no something times something. There is something minus something, but there's no something times something set equal to 0. But we know a cool idea up here that is going to help us get it ready. Okay, so let's do it. What can I divide both 18 and 27 by? Well, that number is 9. What can I divide z squared and z by? Well, that is z, the smallest of the two. 18 divided by 9 is 2, and z squared divided by z is z. 27 divided by 9 is 3, and z divided by z is nothing. Or 1, I guess. They cancel out. Okay, so now I've got an a times a b. Okay, now I'm ready to solve or apply the zero product property, right? So what makes this 9z equals 0? Well, divide by 9, z. When z equals 0, that will make this whole thing 0. Okay, what else will make this whole thing 0? Well, let's solve this thing, and I think we'll find out. When z equals 3 halves. So if z equals 0, then this whole thing is going to equal 0. We have solved the equation. And when z equals 3 halves, that will make this 0. So it'll make this whole thing 0, which will be a true statement, which will be a solution to this equation. So those are the two ideas I need you to have from this. Go ahead and flip over. You'll see a bunch of practice problems. All of these on top are just factoring out our GCF using the distributive property. Then all of these are applying that idea. Oh my goodness. Sometimes we need to set it equal to 0 before we can do something, though, right? Because that's the whole idea. The whole idea is that this thing, we have to have two factors that is set equal to 0. So what are they doing here? Like, why would they do that to us? Well, actually, chill out, okay? Because it's not that hard. I'm going to subtract 27y from both sides, and I'm going to get 9y squared minus 27y equals 0. Now you're ready to go. But the first thing you must do in all of these problems is make sure it is set equal to 0. You cannot do anything to it until you do that, okay? We don't want to divide by this thing on both sides, or we're going to lose one of our y's, which means we'll lose one of our solutions. That'll be just no bueno. But if you subtract this from both sides, then you'll be able to apply your rules that we learned on the back. All of these, except for this one, are going to need you to factor out a GCF before you solve the equation. Let me know if you have any questions, and good luck.